Okay, so here we're going to talk about or focus on symmetry of quadratic functions. And we're going to look at this both from the vertex form, which we have focused on already, as well as what we call ABC form, or sometimes it's called standard form of a quadratic function. So, moving on. Here we have a quadratic function, not in vertex form. So this is what we call ABC form. And what I want you to do is I want you to fill out this table for the given x values, use your calculator to help, and then sketch the graph of that. Do that, just A, pause the video, unpause when you're ready to discuss. Okay, so hopefully your graph looks like my graph here, and these are the points that we came up with, and again, hopefully you use your calculator to help you with that. Maybe you're asking yourself, great, why did I type this into my calculator? I already know how to do that, we're not learning anything new. Okay, hold on. So we want to now we want to use the results of what we just did in part A to identify the vertex of the parabola. So that's something we've talked about before. From the graph, you should be able to do that, as well as from the table. And then I want you to find a vertical line on your graph so that when you fold the paper, the left portion of the graph coincides with the right portion of the graph. What's the equation of this line? And how does it relate to the vertex? So think about if you fold two things so that the left side is the same as the right, that's what we mean by coincide, or is on top of the right, then another way to talk about that is symmetry, right? Like if you were to draw a line down U and fold U in half, hopefully the left side is going to be pretty close to the right side. Now with people there are, some minor differences, but in general it should be pretty close. So that would be the line that we're talking about. So I want you to find that line on the graph. And then the last thing I want you to do is see if you can come up with a way to show that this form, which is vertex form, is the same thing as the form we were given in part A, this form. So how could you show that those two equations are actually the same equation? So pause the video, try to do B, C, and D, and then unpause when you're ready to discuss. Alright, so hopefully you got the vertex is the point 2, -4. And how did I get that? I looked at the lowest point, in this case on the graph, that is 2, -4. Now, for the next part, so find this vertical line, right? Well, I looked at the graph, and I noticed that if I draw a vertical line here, if I was to take the right-hand side and fold it over that vertical line, it should land on the left-hand side. Another way to think about it is from this line to this point is the same distance as from this line to this point. And I can say that at every point that I have plotted. And then the vertex goes through that line. So this line here is the line. What is the equation of that line? Well, anytime we have a vertical line, the equation is always x equals a number. Since the x-coordinate at every point on that line is 2, it's x equals 2. How does it relate to the vertex? It's the same as the x-coordinate of the vertex. So this line is going to go through the vertex at the x-coordinate of the vertex. This is what we call the axis of symmetry. Now, last part, we want to show that the vertex form is the same as the ABC form that we had. So, what did I do? I just multiplied this out and combined like terms. So the first thing I said f of x equals 1/2 times x minus 2 times x minus 2, because that's the same thing as x minus 2 squared. Then I distributed, and I got x squared minus 4x plus 4. Then I distributed the 1/2, so I became 1/2 x squared minus 2x plus 2, and then still minus 4. And then I just combined the like terms, so 2 minus 4 is -2. So I get 1/2 x squared minus 2x minus 2. So those are the same. Great. Alright, next one. Now, the only thing new is this axis of symmetry. So I want you to label the vertex here. identify the vertex, identify the axis of symmetry, and sketch this graph. Pause the video, unpause when you're ready to discuss. Alright, so hopefully we identified that the vertex is the point -3, 4. The axis of symmetry then has to be the equation x equals -3. What else is going on here? This is a -2 in front, so there's going to be a vertical stretch and a reflection, or a flip. So I plotted the vertex, and then I plotted a couple of extra points. You can use your calculator to help you with that, and then I drew the sketch of the graph. I drew the axis of symmetry. Notice how I made it a dashed line here. That's more how you will see an axis of symmetry, because keep in mind, it's not an actual line on the graph, right? We're only drawing it in as a representation of this thing of symmetry, but really it's kind of like an imaginary line. It's not actually there, but it is the axis of symmetry. So that's why a lot of times we'll see a dashed line. All right, so now kind of formalizing some stuff, and this is going to be really big. So this shows us how we can go from ABC form and still identify that axis of symmetry, which, remember, is also the h value of the vertex. So this is huge. So this right here is really important. So whenever we have the form fx equals ax squared plus bx plus c, if I have a graph, I have my axis of symmetry, x equals opposite of b, or -b, over 2a is going to be the axis of symmetry, which, remember again, is the h coordinate of the vertex. We know that if a is positive, the graph opens up. If a is negative, the graph opens down, because then it has a flip. And then a couple of other things to point out. The y-intercept is the point 0c. So remember, to find the y-intercept of any graph, you plug in 0 for x and solve. The nice thing about this form is if I plug in 0 for x, all of this stuff goes away, and I'm left with just c. So the y-intercept, if I have a quadratic function in ABC form, is just the point 0c. And then, as I was mentioning already, the vertex is going to be the point opposite of b over 2a, because that's the same as the axis of symmetry. That's the x coordinate of the vertex. And then the y coordinate we would get by taking that number and plugging it into the function for x. So that's what this notation is saying. It's just saying take whatever that value is and plug it into the function for x, and that will give you the y coordinate. So let's do an example. All right. The order in which we do this stuff does not matter. So I'll be totally honest, I'm going to find the y-intercept first, because that's really easy to do. So if I make this 0 and I make this 0, this is my c value. I know my y-intercept is the point 0, 1. Okay, great. Now let's find the vertex. So h is going to be opposite of b. So I'm going to do negative, that's opposite, of -6 over 2 times a. So whenever we have a negative times a negative, that becomes a positive. So this is 6. 2 times 3 is also 6. Anytime we divide two things that are the same, we get 1. So h is 1. To find the k value, I know that I can take that value and plug it into the function wherever there's an x. So f of 1 is going to be 3 times 1 squared minus 6 times 1 plus 1. 1 squared is 1. 3 minus 6 is -3. -3 plus 1 is -2. So f of 1 is -2, which means k is -2. So my vertex is the point 1, -2, and my axis of symmetry, I'm just going to say axis of sim, is x equals 1. Now I want to point out it's a complete coincidence that the y-intercept had the same value as h and our axis of symmetry. It is not a complete coincidence because they will always be the same, that this value and this value are the same. So now let's do a little graphing. We know our vertex is 1, -2, and we have a y-intercept of 0, 1, which means I have to have a point here. So my parabola is going to look something like that, and that's my axis of symmetry. Questions? Okay. Nice work. Moving on. Alright, so now I want you to try these on your own. You're not graphing them now. You're just finding the vertex, the axis of symmetry, and the y-intercept. I want you to try all 4. I believe you can do this, because I believe in you. Pause the video. Unpause when you're ready to check. And if you get stuck, just unpause it early and listen to me explain. It'll be a nice soothing voice like this. Alright, pause the video now. Alright, so the work for the first two is a little bit different than the work for the second two. So the first two, it's really easy to find the vertex and the axis of symmetry because this is vertex form for both of these. So therefore the vertex is right there, which means the axis of symmetry is also right there. So the vertex for the first one is -1, 0 because this is x plus 1. That's where we get the -1, and then there's nothing added or subtracted outside of that. Therefore the axis of symmetry is x equals -1. The y-intercept, we actually have to do a little bit more work since this is not in the ABC form. So for the y-intercept, remember to find any y-intercept, we plug in 0 for x. So that's my work down here. I plugged in 0 for x, and then I simplified, and I ended up with -3, so the y-intercept is the point 0, -3. Here the vertex is 2, 5. The axis of symmetry is x equals 2. And then to find the y-intercept, again, I plugged in 0 for x, did arithmetic, got 13, so my y-intercept is 0, 13. For 3 and 4, now these are in ABC form, so the y-intercept is really easy to find, but we have to do a little bit of work for the vertex and the axis of symmetry. So the y-intercept for 3 is 0, -1, because my c value is -1. The y-intercept for 4 is 0, 1, because my c value is +1. Then I used opposite of b over 2a for both of these to find the h coordinate of the vertex. So for 3, I got -2 over 2 times 1 is -1. If you're confused, the 1, remember, if nothing's written in front of the x squared, that's an a value of 1. For 4, I did negative, so that's my opposite, times -8, because b is -8, over 2 times -2, that's my a value, which simplifies to -2. To find the k value, I take that h value and I plug it back into the original function wherever there's an x, and I simplify that. So for 3, I got -2, 4, I got 9. Now I know my vertex is the point -1, -2 for 3, which means my axis of symmetry is x equals -1. And for 4, my vertex is the point -2, 9, which means my axis of symmetry is x equals -2. Nice work. I knew you could do it. Okay, so now we've kind of seen most of the main key features of a quadratic function. So the big thing is making sure to identify when we have vertex form versus ABC form. Either of those forms can give us the y-intercept and the vertex and the axis of symmetry, but we need to understand the form so we know what to do to find each of them.